Alright, so what we're going to do is we're going to cover the real number system for beginners. Alright, what do we think of when we think of numbers? Usually we think of how we first started counting as children, and we start off with the number 0, then the number 1, then we went to 2, then the 3, then the 4, then the 5, and then so on. Alright? This is actually something in the math world we call the natural numbers. Alright? So this funny looking n, we're going to use shorthand for the set or the natural numbers. And the way we express this in the math world is by writing it in the following manner, like this. And what I've done here is I've denoted the set of natural numbers. Alright? You may be asking yourself, what is a set? Well, it's just a collection of objects. Alright? In this case, the collection of objects are the numbers 0, 1, 2, 3, 4, 5, and this dot, dot, dot right here is signifying that this pattern that we've established continues. Alright? Another thing is that this set of natural numbers here is in no particular order, meaning I can have 5, 4, 3, 2, 1, 0, and then the other natural numbers in there, which go on, by the way, to some infinite value. And it would still be the same set as this. However, it's good to use this method of writing out a set because we can establish a pattern with very few elements of the set, right? Each of these guys are elements of the set. So, if we have the set being a collection of objects, we can say that the objects in a set are the members or elements of that set. Alright? And again, what we can do with this is write just a few elements of the set to establish the pattern such that we can use this dot, dot, dot to say, hey, this pattern is repeating. So we go from 4 to 5 to 6 to 7 to 8 to 9 to 10 to 11, blah, 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 on and on and on. Alright, so we know that in the set we have a collection of objects. The objects themselves don't have to be numbers. Alright? So, now that we have that established, you might be thinking to yourself, well, why are we going through the bother of identifying what a set is? Well, like I said, the set of natural numbers are those numbers that we first learn to count with. Alright? We can also kind of extend ourselves from the set of natural numbers and say, okay, I can have a 0, a 1, a 2, and a 3, this pattern gets established. Alright? And at some point we realize, hey, you know, we can have values of -1 and -2 and -3, and likewise, as we've established a pattern going from right to left, using this ... saying we go from 2 to 3 to 4, we can establish this pattern from left to right from 0. Sorry, go left to right in this from 0 to 3 and right to left, giving some negative values of -1, -2, -3, and establishing that pattern, meaning we go from -3 to -4 to -5, so on and so forth. I can call this I, where this I will mean the set of integers. Now what I have are all those positive integers, all those negative integers, and 0. Okay? And we can do kind of a set of even integers, right? That would be 0, 2, 4, 6, 8, ... Actually, we can include negative integers as well in there, so -6, -4, -2, 0, 2, 4, 6. And of course, the set of even integers are those integers that are just divisible by 2, or multiples of 2. And we can certainly say that about negative integers as we can of positive integers. Alright? The set of odd integers, I'll just go with 1, 3, 5, 7, 9, so on and so forth. Basically all those integers that are not even integers. Alright, and that is another key aspect of what we're doing here with the real number system. I didn't include negative odd integers in here because, well, I just didn't feel like it, but you could if you wanted. Alright, so we're expressing a lot of collections of numbers or collections of objects using this idea of a set. Alright, we're collecting the objects. We know we have a set when we have these kind of squirrely brackets right here, and this signifies a set in a roster form. Alright. And believe it or not, all these sets that I've established in roster form, okay, all these sets are members of the real number system. Okay, so what I want to do now is give you sort of the key part of what makes up the real number system. Here we go. So what we can say about the real number system is that they are kind of broken into two different categories. Rational numbers and irrational numbers. And what we're going to do now is use another sort of idea in set theory, if you will, that will define what a rational number is versus an irrational number. Alright? let's talk about the set of rational numbers. And I'm going to express it in a different sort of notation using the idea of a set. Here we go. I'm going to have this squirrely bracket right here that signifies we are collecting a bunch of objects. Then I'm going to write some p, and this p is being used as a variable, alright, as is this q. Then I'm going to have a straight line, or a partition if you will. Alright. Then I'm going to say p and q are integers. Alright, and q does not equal 0. Alright. Obviously when we have something equal to, not equal to something else, we put an equal sign with a line through it. We say p and q can represent any integer, meaning p and q can be any of these values that are found in a set of integers right here. Alright? It could be positive, it could be negative, it could be 0. And what we have is something called sort of a set builder's notation. Or the way I like to think of it is kind of the blueprints or the plans for how to build the set of rational numbers in roster form. So this is kind of telling us if we were to build the set of rational numbers in roster form from scratch. This is how it's done, and these are the conditions of how it's done. Alright? What we can do is, first I can let you know that this is called set builder's notation, which is something I just mentioned. Alright? And then what I'm going to do is I am going to translate this into plain English, into one, sentence. So, here we go. The set of all values p over q such that p and q are integers and q cannot equal 0. Alright? So the set of all values, right here I'll use a squiggly underline, is signified by these kind of squirrely brackets. Anytime we have these squirrely little brackets open and close and we have stuff in between, we're collecting a set of objects. We're collecting objects signifying a set. Alright? P over Q obviously matches up with that P over Q right here. Now the such that, I'll box it out, goes with that partition. Alright? And then the conditions. So this first bit, including a partition, is pretty much saying kind of, I would say 30% of the blueprint, or